In lesson 5.2, rewriting percent expressions, we're going to work on 7.EE2. EE stands for expressions and equations. Understand that rewriting an expression in different forms in a problem context can shed light on the problem and how the quantities in it are related. So our essential question then is, how can you rewrite expressions to help you solve markup and markdown problems? If you remember, I talked about in the Module 5 background, I gave the general information about markup and markdown problems. So if you haven't reviewed that yet, you probably should go ahead and do that right now. In this lesson, we're going to talk about a percent can be written as a decimal or as a fraction. Depending on the problem, one of the two forms may provide a more efficient solution than the other. A markup is an example of a percent increase. The term markup sometimes refers to a percent increase. A markup of 20% on $150 is a markup of $30. A markdown is an example of a percent decrease. So in example 1, if you go ahead and read the word problem here, I'm going to go ahead and just start marking the important information here. What's the retail price? The manager buys for $35 and $56, so there's two problems. Each one is going to have a 42% markup. So when you see markup, you should expect that your final calculation for price should be higher than what your original one is. So they talk about using the bar model here. So we draw that. And then S is going to represent the original price. So the first thing we're going to look at is we're going to look at $35. But what they're showing you here in the bar model is that this is 100%, because that represents what S is going to be. Another way that we can write that, remember, if we take 100, because we're going to convert 100%, we're going to convert that into decimal. 100 divided by 100 is going to equal 1. 1 times S is equal to just S. Remember, 1 times anything is always whatever that anything is. 100, the number divided by itself, is always equal to 1. So this is the concept behind understanding how we get to that. The 0.42 is when they took the 42% and they divided that by 100 and you got 0.42. So what they're showing you here is they're taking the 1S, which I just previously showed you, and they're taking the 0.42, and since it's a markup, it's going to be the original price plus the 42%. So they have this shown in decimal form, and I showed you, I remembered really the number 1 is in front of the S there, okay? The number 1 is really in front of the S. So 1S plus 0.42S, okay? Now, if you remember in your basic addition, these are like terms, the S's, so you can add those two together. So 1 plus 0.42 becomes 1.42, and we put the S at the end of it. So this is going to be one way that you can show, and this is going to be another way that you can show how your markups are. So this is what they show you down here. The original cost plus the markup equals the retail price. So they go through the steps where we take the 1S plus 0.42 equals the 1.42. So now they've gone ahead and substituted in the $35 and substituted in where S would be. Okay, so that's right here. So 1.42 times $35, and your final retail price then is going to be $49.70. They also do the same thing for the $56. Substitute the 56 in, so 1.42 times 56 is going to equal $79.52 as your final retail price. When they ask you to write two expressions, okay, what they're talking about is what is two different ways that you can come up with. So if I actually take these two and put them side by side, 1S plus 0.42S equals 1.42S. So this is going to be one expression, and this is the second expression. So this is the original cost plus the markup, and then this is the way the total price of the retail. So if we take a look down here in the your turn, Rick buys remote control cars to resell. He applies a markup of 10%. Write two expressions that represent the retail price of the car. So what we're going to do, first we're going to convert this into decimal, 0.10. So the first expression, the original cost, all right, we have to, it's not explicitly stated here, but you have to remember the original cost. Original cost plus the markup is one expression. So the original cost, remember, is 100%, or it's going to be 1. So that's 1 plus 0.10, and I'm going to go ahead and use C for the car, okay? So that's one expression. But now if we go ahead, oops, I should have put the C there. So 1C plus 0.10 is also equivalent or equal to 1.10C. So this is the second expression. First expression, second expression. What this tells you is this tells us what the original cost is going to be, plus what is 10% of the original cost. And if we go ahead and add those together, this tells us what the final cost is going to be at 1.1, which is 110% of the markup. So if Rick buys a remote control car for $28, what is his selling price? Well, this is the original cost. So that's going to be 28. Okay, that's the original cost. And we're going to do 10%. So we're going to do plus 0.10 times, this is a parenthesis, times the 28 equals, what's that equal? So, well, what's 10% of 28? Well, so we're going to do 28 plus 2.80, because we're actually $2.80, because that's 10% of this. Let you do the math on that. And we add those two together, so then we're going to get $30.80. Okay, so that's one expression. The other way that we're going to do that, we're going to go ahead and take 28 times 1.10, okay? Because really what I did, I took this 28 and I put it into this position right here. So it's going to be 1.10 times 28, and that's going to come out to $30.80. This is the second expression. This is the first expression. This is the second expression. Now, notice the difference here. The second expression only tells us the final cost. It doesn't, you can see the original cost, but you don't know what the markup is. So to find the markup, you're going to have to take the total minus the original, and then that's going to give us the markup, who's called MU. So you take the $30.80 minus the 28, and we should come up with the $2.80. So we can, this is our markup. So you can find it, but there's a different way that you got to do it. This way, in the first expression, you already know the original cost. You found the percentage of the original cost, and then you add those two together and you find the total cost. That's really the whole gist about everything. Markdown is going to be the subtraction. You're going to take 28 minus $2.80, and you're going to get a new value. So let's go on and see what we got. So here we're going to look at markdowns, okay? Also could be known as a discount. Markdowns could be a sale price that you're looking for. In this example, discount store is going to take 20% off for the holidays. Guess what's coming up? 20% off. Find the discounted price if you sell them at $16 and those that you sell at $23. So again, you have two problems going here. So now what we have shown in the bar model, P represents the original price. Okay, so you're going to have 16, you're going to have 23. And then 20% is the 0.2. So remember, 20% divided by 100 equals 0.2. So you take 20% of the original price, then you take the original price and you subtract that 20%, and that gives you what your final markdown is going to be. So here they show you the original price, again, just like what we did for markup, but this time you're going to subtract. That's the key right there. You're subtracting the markdown. You're going to take 20%, okay? But notice here, you take 1 minus 0.2 and we get 0.8p. So I'm going to put that over here because that's our, when they ask for the two terms, this is going to be one term. So you know the original price, you subtract the markdown percentage, and that gives you this. So the other way that you can do that is by taking 100% minus the 20%. Remember, this is just decimal already, and that's going to equal the 80%. Okay, so then you could take, you could divide that by 100, and that gives you the 0.8. And you could take your original price then and multiply that, and that will tell you what your total is. So two different ways that you can, two different expressions that you can come up to figure out what your markup, markdown is. So here they take the one Christmas decorations or the decorations at $16 times that by 0.8, so they're using this expression, and you get $12.80. And then they take $23 times the 0.8, again using this expression, and you're getting $18.40. What we don't know is we don't know how much was the markdown from the original price. So you would take, using this one as an example, you would take the 23 minus the 18.40, and that's going to give you whatever that value is. You can go ahead and calculate that out. Bicycle shop marks down each bicycle selling price B by 24% for the holiday sale. So we go ahead and draw a bar model. So the original price, we just, make it like that. So that's going to be B, and then we're going to have some other price over here, and that's going to be our 24%. So then this is going to be subtracted right here. Okay, so this amount is this amount. So then if we take 100% minus our 24%, okay, so then we're going to come up with 76% is what's going to be left. So that's what represents this amount right there. That bar is going to be 76%. What is a single term expression for the sale price? So if you look up ahead, up above, you can see what you're going to come up with to fill in there. Again, look, write two expressions that represents the sale price. You're going to be using 5%. The examples above do a really good job to help you out. You have the guided practice here. You're going to go through, again, figuring out, or you have the markup, markdown. This one's a markup problem. Go through the examples. Notice here they reference you to the examples that you can use to help you out. Same with the example one here and doing the table. This is that change original price markdown, again using example 2. So I hope this helps you out. If you have any questions, please let me know.